Hey guys, in this video we're going to be looking at the equations of exponential functions. So we've talked about an exponential function. Here you can see we have the exponential function is in blue. And we talked about these in terms of graphs and in tables and in geometric sequences, finding the base and finding the initial value. And then many moons ago we've talked about linear functions and how we can build a linear function from the y-intercept and then the slope, which is the value that's added to the y every time the x progresses by 1. So what we're going to look at today, and what I want you to get out of this video, is that by the end of it, I need you to be able to write an exponential equation. So you should be able to look at a graph or look at a table and write the equation for that. But before we do that, let's look at, for a linear function, how we wrote the equation. And this will help us remember, or this will help us understand how to do this for an exponential. So in a linear function, we have two important values. We have the y-intercept and we have the slope, the rate of change. And both of those appear in our equation. The slope is what we multiply times x, and the y-intercept is either added or subtracted, depending on if it's positive or negative, at the end of the function. So if I know my slope and I know my y-intercept, I can plug in those numbers and I can build the linear function very quickly. With an exponential function, it's very much the same. I just have to know the general format, I have to know what the values I need to plug in are, and then I have to find those values. So here we go. For an exponential function, the equation will look like this. Y equals, or f of x or g of x or whatever the name of the function is, equals some number times some other number raised to the x power. So that means the x, the variable on this, is actually an exponent and will be written in superscript way up above the number. And these two numbers, both of them are 3 in this case, just like in a linear function, are two of the parameters we're looking for. So the first one is the initial value, also called the y-intercept. And so we just write whatever the y-intercept is there. And the second number, the one raised to the x power, is simply the growth factor, which is also called the base. So from the last quiz cycle, you were able to find the initial value and the growth factor. That should make it very straightforward to write an exponential equation. The key here is remembering that format. Y equals some number times some other number raised to the x power. So now what we can do is we can look and we can see if we can identify one of these out in the quote-unquote wild. Here we have 4 functions, f of x, g of x, h of x, and j of x, and we are asked which is an exponential function. So remember, an exponential function looks like some number times some other number raised to the x power, and I'm going to give myself a line tool here. Alright, now we're ready to go. Let's take a look first at f of x. Here we have some number times x plus some other number. We recognize that that's linear. That cannot be an exponential function. Let's take a look now at h of x. We have exponents in here, which is promising, but we have the x variable appears twice, which is not going to happen for our exponentials. And also, in an exponential function, the variable has to be the exponent. It has to be raised to the x power. So h of x, sorry my friend, you are not an exponential. For j of x, we're a little bit closer, except we're adding these two. In an exponential function, we need to multiply those two. And also the variable is not raised to the x power, so it's not that one. And then finally, here we have g of x. We've got some number times some other number raised to the x power. That right there is what we're looking for. And we can say that this one is indeed our exponential function. That's the one we're looking for. Another thing we can do, and this is just good practice because I want you to be thinking of this equation in terms of these important parts, is I could ask you to find the initial value and the base. Remember, base is just another word for growth factor of this exponential function. And all you have to do is read those out of the equation. The number that we're multiplying by first that has no variable with it is our initial value. So our initial value is just 4 right there. The base, the growth factor, is the number raised to the x power. So in this case, my base is going to be 7. So I can find the initial value and the base very quickly if I'm given the equation. So now let's talk about how I could take either a table or a graph and write these equations for myself. In order to do this, first thing I have to do is find the initial value and find the growth factor, and then just substitute them into that form of the equation. So for this table, let's find our initial value first. The initial value, you'll remember by definition, is the y-intercept. It's the y value when x equals 0. So in this case, the y value when x equals 0 is going to be 3. So I just put that 3 in for my initial value, just like that. Now the base is the number I'm multiplying by each time that x increases by 1. So here I've got x increasing from 0 to 1, and my y value is multiplied by 2. 3 times 2 equals 6. And I can check that to verify. 6 times 2 is 12. 12 times 2 is 24. If you can't just inspect this and look at it and know that 3 times 2 is 6, what you can do is take the second number divided by the first number. 6 divided by 3 is going to give you 2. And as long as the y values you're doing this for are only separated by one x value, so 12 divided by 6 is 2, 24 divided by 12 is 2, and my base for this equation will be 2. So I write it right in there. And now I've written the equation for this table. Y equals 3 times 2 to the x power. So let's try that for some others. We can look at this graph, and if I'm going to write the equation, I need the initial value, I need the growth factor, and then I need to just substitute those into the equation. So my initial value I find by looking at the y-intercept, and here I can see if I look very closely, I realize those lines might be very faint for you, but the y-intercept here is going to be 1. So my initial value is just 1, easy as that. To find my growth factor, I use the initial value being 1, and then I go over here to where x is equal to 1, and I trace that up and find the y value there, and it's going to be 4. So if my y value goes from 1 to 4, I can do 4 divided by 1 and find my base, or my growth factor, to be 4. Now that I know those, I can just substitute them in to find the equation. Y equals 1 times 4 to the x power. So again, that 1 is my initial value, times, there's the little dot there for times, my growth factor raised to the x power. So y equals 1 times 4 to the x. We can do this for a table as well. My initial value is the y value when x equals 0. So the initial value here would be 9. And then I need to find my base. What am I multiplying by? These two are separated by an x value of 1. So 54 divided by 9 would be 6. So that's my growth factor. And then I can just substitute those into the equation. So I would get y equals 9 times 6 raised to the x power. So again, the initial value first times the growth factor raised to the x power. And this is pretty much all there is for basic exponential equations. Again, it's just remembering what the two important factors are, finding them, and then substituting them in appropriately into our standard exponential equation. We will be using this for the rest of this module. Make sure you master this skill. It will be very, very necessary. Later on, we'll add a little bit to this equation and make it slightly more complicated. But if you understand this basic part, then you are in good shape. Good luck.